So on this slide, I want to combine all of the angles in both degrees and radians all onto one unit circle. So this is going to include the circle that was broken up into 8 sections and the circle that was broken up into 12 sections. So let's start with the 8 section one. So my 8 section one, remember that it goes by 45 degrees and basically everything's broken up into halves, right? So if this is 0, right, then halfway to the 90-degree guy would be right there, and then we have our 90 degrees, then halfway. So this is the 8 section one where the difference in the angles is 45 degrees. So I know that if I start here at 0, right, then if I go up one more, this is going to be 45, then I'm going to end up at 90, then I'm going to end up at 135, then I'm going to end up at 180, then this is going to be 180 plus 45 is 225, then 225 plus 45, that's 270, 270 plus 45, that's 315, and then 315 plus 45, I'm back to 360. Perfect. So now let's go ahead and do the exact same thing, but in radians now. So in radians, let's do radians in red. Red radians. So we know that radians, we're going to start at 0 radians. And then when I go here, the distance between each one is just pi over 4. We know this one is 2 pi over 4, which is the same thing as pi over 2. Then we know this one is 3 pi over 4. Right? Then we know the next one is going to be just pi. Then we got this piece right here is going to be, well, that was 4 pi over 4, so this is 5 pi over 4. Then this next piece is going to be 6 pi over 4, which simplifies to 3 pi over 2. So that is 6 pi over 4, so this is going to be 7 pi over 4. Then I've got 8 pi over 4, which is the exact same thing as 2 pi. Now let's look at it. Now let's look at the 12 section guy, right? So now I'm going to break this up into 12 sections. So the 12 section is going to break up things into like thirds, right? So here we start at 0. Then I've got my third, right? That's 1/3. Then that's my second. That's my third. And so on and so forth, right? So that's broken up into 6 sections. Now I can go ahead and continue the rest. This is all my 12 section guy right here. Perfect. So now I'm going to go ahead and let's do this. Let's find the angle measurements of the guys in purple. Actually, let's continue using black for degrees. And remember, this one just goes by 30. So 30, 60, then 90 is already there. Then 90 plus 30, that's going to give me 120. So this angle is 120. 120 plus 30, that's 150. Right, then that's 150 plus 30 is 180. 180 plus 30, that's going to give me 210. 210 plus 30, that's 240. 240 plus 30 is 270. 270 plus 30 is 300. 300 plus 30, that's going to give me 330. And then 330 plus 30 is 360. And I'm done. Let's go ahead and look at the radians now. Remember, with radians, it goes by pi over 6s. So here, this is going to be pi over 6. Then this will be 2 pi over 6, which just simplifies to pi over 3. Then this will be 3 pi over 6, but that is reduced to pi over 2. Then this next piece is going to be, let's see, 4 pi over 6, which is going to become 2 pi over 3. So then I've got 5 pi over 6 right here. Let's just put it over here. 5 pi over 6. Then I've got 6 pi over 6, which is pi. Then I've got 7 pi over 6 here. So 7 pi over 6. Then I've got 8 pi over 6, which is the same thing as 4 pi over 3. Then I've got 9 pi over 6, which is the same thing as 3 pi over 2. Then I've got 10 pi over 6, which is the same thing as 5 pi over 3. And then I've got 11 pi over 6. And that doesn't simplify. And then I've got 12 pi over 6, which is 2 pi. And there we go. Now we have the unit circle with all angles and radians. I'm sorry, all angles in degrees and radians. So now we're moving on to the third objective, which is going to be to identify the points where the angles and the unit circle are going to intersect. So the first thing I want to do is I want to look at the quadrantal angles, right? So let's start looking at these quadrantal angles. So let's start with the easiest one, which is 0, right? So I want to know what is the point, right? Where's the point where the unit circle, so the unit circle is going to be this piece. This is the unit circle right here all around. So where does my unit circle, the piece in purple, and my angle intersect? So I want to know what is the point, right? This is a point. This is a point right here. So we need to know the measurement of this line here. Well, we know it. We know that the radius of the unit circle is 1. So how would I describe this point, right? If I start here at 0, this is the point, this is my origin, this is 0, 0. If I start at 0, 0, how do I get to this point to the right? Well, I go 1 unit to the right, and I do not move at all up or down. So that's the point 1, 0. Now let's go to the next quadrantal angle. So for this quadrantal angle, right, I want to know how do I get to the point where that angle intersects the unit circle right there. So what is this point going to be right here? Well, we know the radius is equal to 1. So I travel 1 unit straight up from 0, 0. So I don't move at all in the x direction. I move up 1 unit. Done. So now let's go to the next quadrantal angle. I know my radius here is 1, but now I am traveling. So now I'm traveling to the left from 0. So that means it's going to be negative, right? So I go left 1, and I don't move at all up or down. And then my last quadrantal angle, I'm going to go straight down. I'm going to see where does this point intersect? When does it hit the unit circle? And I notice that, oh, I cannot zoom in anymore. All right, here we go. So I notice that this point, I go down to get to it, right? I don't move at all in the x direction, and I move down 1 unit to get to that guy. All right, perfect. So we have all of our quadrantal angles done. I'm going to go ahead and erase these values. That way we can focus on the next part. So now the next part is I want to find where do these angles intersect the parts on the unit circle that are not quadrantal angles. So where does this angle hit the unit circle? Now this one's going to be tricky because even though the radius here is 1, right, that doesn't mean that this point is going to be 1. How do we find this point? Well, we're going to have to do 2 things, right? I'm going to have to travel. I'm going to see how far I travel in the x direction, right? This is my x value. And how far do I travel up from that point? And that's going to be my y value. So this point is going to be made up of an x and a y value. The x value is going to be, well, whatever the side of the triangle in blue is going to be, and then my y value is going to be, well, whatever the height of that triangle is. So let's go ahead and let's see if we can fit one of our special right triangles onto here and see if we can find what those values are. So we know from the previous slide that this angle here, that the first angle, right, from here to here is going to be 30 degrees. Right, so that tells me that I'm probably going to use a triangle that has an angle of 30 degrees. So I'm going to try this one right here. I'm going to grab this guy, and I'm going to see if it fits there, and it does, right? Pretty close, right? It's not going to be perfect, right? I just made these triangles up really quick, but yeah, perfect. That's going to fit right there. So we can see. That whoops, let me go ahead and put that triangle back. There it is. So we can see that the x value to this shape is going to be radical 3 over 2. And my y value is going to be 1/2. All right, so we're going to do that with the remaining triangles. So now let's go ahead and let's look at the next triangle. So we know that the next angle is going to be 45 degrees, right? We know that this angle from here to here is 45 degrees. So I'm going to try out my triangle that has the 45-degree angle. So I'm going to try this one out. Take that guy, I'm going to put it right there. Perfect. It fits there perfectly. So, well, maybe not perfect, but that's okay, right? We get the idea, right? So this point here is going to be made up of how far I traveled in the x direction, how far I traveled in the y direction. So my x direction is this right here. This is my x. So radical 2 over 2. Then the y value is going to be the exact, is going to be the y is going to be whatever this value is right here, my y value. So radical 2 over 2. Perfect. Now let's get the next triangle. So now we're moving on to the next triangle. So here it is. Perfect. I'm going to grab this guy and it fits pretty good on there, the 60 degree. So I'm going to go ahead and find the points. So right at this point right here, we know that the x value is going to be 1/2 and the y value is going to be radical 3 over 2. Perfect. So there's the first quadrant. Okay, so now that I use my special right triangles to find the measures in the first quadrant, I could continue using the special right triangles and applying them to every quadrant after that, but I think an easier way would be to use properties of reflection in order to get the remaining points. And this is also useful to help you kind of memorize what we're doing here. So we're going to go ahead and start off with this, with our first angle here at 30 degrees. Right, this angle. Now we're going to have a similar angle on the other side of, in the second quadrant of this unit circle, and it's going to match up with that angle right there. So if you guys remember reference angles, so this is 150 degrees right here. Now if you notice, each of these angles are both going to have the exact same reference angle, right? This is 30 degrees, and this angle right here is also going to be, the reference angle is also going to be 30 degrees. So that's why the values are going to be the exact same, because they are the exact same triangle. So by using reflection, the measurements of this triangle are going to be the exact same as the other one, except going left is just going to make my x value negative, right? So let's take our values. Our radical 3 over 2 and 1/2. So now this is going to become negative radical 2. So negative radical 3 over 2 and 1/2. Right? Let me double check it. Yep. There it goes. Now let's go to the next one. Right? Let's take a different angle. This angle right here is going to have the exact same reference angle as this guy. Right? So what I'm going to do is I'm just reflecting. I'm just taking this measurement and I'm just reflecting it across. So all we got to do is just rewrite. Those are easy because they're this exact same values. So these are going to be radical 2 over 2, comma, radical 2 over 2. But when I go on to the left, this is now going to be negative. Let's do the last one. So now my last one is, I like darker colors. Let's do purple. So here, this is my last guy. This is going to match up with this guy right here, right there. I'm going to reflect this point across. And again, they're going to have the exact same reference angle. So now this measurement is going to be, so it was 1/2 radical 3 over 2. And the x value now is negative. Right? So there we go. We can do the exact same thing in the third and the fourth quadrant. So I'm going to go ahead and do that. But I'm going to put a little, I'm going to help us out a little bit, is in the third quadrant. The third quadrant, we know all the points are negative. And then in the fourth quadrant, we know that the x value is positive and the y value is going to be negative there. So just like we knew in the second quadrant, my x values were negative and my y's were positive.